Remember in the last video we discussed calculating the probability that event A or B will happen. For example, the probability that a randomly drawn customer from your base lives in New York or Boston. We're also often interested in the probability of A and B happening. For example, you might be interested in the probability that your favorite sports team wins their next 2 games, or the probability that 2 products will both succeed in the market. We'll learn how to do this in a special case here, and then we'll spend a lot of time considering the general case later on. We first need an important concept, the concept of independence. So 2 events are independent if knowing that one occurred has no impact on the probability of the other occurring. So for example, 2 consecutive dice rolls are independent. The outcome of the first roll should give me no extra information about the probabilities on the outcome of the second roll. Similarly, the ticket sales for the Boston Red Sox and the length of time on your commute on a winter day in San Francisco probably are also independent. Knowing that one happened or the length of your commute doesn't give any information on the probability that ticket sales will be high or low. However, perhaps ticket sales in a small town will not be independent with box office sales if there's a popular movie. In other words, if you know the box office sales are high, the probability of high ticket sales for the Red Sox game will be low. So once we have independence, it turns out that it's pretty easy to calculate the probability of A and B. The probability of A and B for 2 independent events is the probability of A times the probability of B. As an example, what's the probability that I pull a 2 from a deck of cards and a diamond simultaneously? Now, drawing a 2 intuitively doesn't tell me anything about whether or not I drew the suit diamonds. And so these are independent. So I can write the probability of drawing a 2 and a diamond is equal to the probability of 2 times the probability of a diamond. So this is 1 in 13, because every 1 in 13 cards is a 2, times 1 in 4, every 1 in 4 cards is a diamond. This equals 1 out of 52, which should square quite well with our intuition when we remember that there's only 1 card out of the 52 that is both a 2 and a diamond. As another example, let's say that you define a really bad day as a day when your stock tanks and it rains. And you know that the probability of your stock tanking is 1 in 4. Maybe you need to change your portfolio. The probability of rain is 1 in 10, or 0.1. Now we'd like to calculate the probability of a really bad day. And if you think about this, rain hopefully is not correlated or is independent from the stock market. And so we can multiply 0.25 times 0.1 to get 0.025. However, let's say that a really good day is a day when it's sunny and the bus is on time. We could try to multiply these probabilities, but first it's important to think about whether they're independent. And it turns out they probably aren't. If you know that it's sunny, the probability that the bus will be on time should be a lot higher. These have been some examples discussing independence and calculating the probability of A and B. We'll go through one more example for the first section, and then our second section, conditional probability, will be all about calculating probabilities when events are not independent.